There are only two types of logarithms that are useful in science. One is the natural log, which is the log base e, and the common log, log base 10. We'll be using common logs in chemistry. Common logarithms are based on powers of 10. If you have a power of 10, such as 10 to the 5th, the logarithm is simply the exponent. Log of 10 to the 5th is 5. Log of 10 to the 10th is 10. Some more examples are shown on the screen. The log of 1 is 0, and the log of 10 is 1. Therefore, the log of a number between 1 and 10 must be a fractional log, and some examples are shown on screen. You have been taught this equation in your math class, that when you have a product, the log of the product is the sum of the individual logs. What I need you to try to learn in chemistry is how to use this equation practically. So let's start with a given. As we saw on the last slide, the log of 2 is 0.3. What is the log of 4? To answer this question, you want to see that 4 is 2 times 2. Therefore, we can find the logarithm of 4 by adding the log of 2 plus the log of 2. This will mean that it's very easy to compute the log of 4 because it's 0.3 plus 0.3, log of 2 plus log of 2 will give us the log of 4, which is 0.6. Now let's see if you can use this skill yourself. Here on the screen is the original equation, and I've given you some logarithms of individual factors. Here's your first question. What is the logarithm of 6? You would like to see this as 6 equals 2 times 3. Therefore, add the logarithm of 2 with the logarithm of 3 to get the logarithm of 6. Here's your second question. What is the logarithm of 12? This could be done in a couple of different ways, but you want to break 12 down into factors of which you know the logarithm. So for example, you could do 2 times 2 times 3. That would give you 0.3 for the log of 2, another 0.3 for the second factor of 2, 0.5 for the factor of 3. That would lead you to the conclusion that the log of 12 is 1.1. You could also get to the same conclusion saying 12 is 6 times 2. We already know the log of 6 is 0.8. Add the log of 2 and you get to the same place. Here's your third question. This is a little different because we cannot make 5 out of the factors shown on the screen. But we do have the logarithm of 2 and the logarithm of 10. And you should know that 2 times 5 equals 10. So here the thinking would be, I know the log of 2 is 0.3. I don't know the log of 5, but I know that together they must add up to the log of 10, which is 1. And therefore, I know that the log of 5 is 0.7. Here's an interesting question for you. So now we're looking at a number expressed in scientific notation, which you should see as a product. 3 times 10 to the 4th. How do we find the logarithm of this number? Let's break it into parts. The logarithm of 3 is 0.5. We know that from the previous slide. What about the logarithm of 10 to the 4th? That's a power of 10. So it is a whole number logarithm. The logarithm of 3 times 10 to the 4th is the sum of the logs of the individual factors. The logarithm of 3 times 10 to the 4th is 4.5. We'll be using a lot of numbers in chemistry that have scientific notation, but the exponent is negative, so small quantities. So we want to be able to take the logarithm of a number expressed in scientific notation that has a negative exponent. The laws are the same as before. This is still a product, so we'll be adding two individual logarithms. What's the log of 3? We know that's 0.5. And the log of 10 to the negative 9 will be negative 9. The sum will therefore be negative 8.5.